2020, paper 1. Question 1. What is the conversion factor for converting megameters to millimeters? 1 megameter is equals to 1 times 10 to the power of 6 meters. 1 millimeter equals to 10 to the power of minus 3 meters. 1 megameter over 1 millimeter equals to 10 to the power of 6 over 10 to the power of minus 3, give you 10 to the power of 9. Question 2. What's the approximate diameter of an atom and the average diameter of Earth? The diameter of an atom is 5 times 10 to the power of minus 10 meters. The diameter of Earth is 12,000 km, which is 1.2 times 10 to the power of 6 meters. Question 3. A stationary object O is acted upon 3 forces. You have 4 newtons, 5 newtons. If you connect them into a triangle, this is 4 newtons here, this is 5 newtons, and you know it's a perfect triangle. Force X is 3 newtons. Question 4. A large metal ball and a small sponge ball are dropped from the top of a building. They are released at the same time. The metal ball reaches the ground first. So, which statement explains this phenomenon? As we know, air resistance is present. Okay, so part A says, option A says that gravitational field affects heavier objects and makes it accelerate faster. No. G is constant at 10 meters per second per second. Option B says that the acceleration of free fall, G, depends on the mass. No. It's weight that depends on the mass, because the formula W equals to mg. Option D, there's a smaller force of air resistance on lighter object. No. Air resistance is proportional to speed. Okay. So option C, the ball reaches a greater speed before air resistance balances its weight. When air resistance balances its weight, the object is said to be in terminal velocity. Next. Question 5. The graph shows how a height of a falling object changes with time. So the height here is actually displacement. So you can see that the displacement is changing, where it's at terminal velocity is when the graph is a straight line. The gradient is constant. As you know, the displacement time graph, the gradient will give you the velocity. So gradient of displacement time graph will give you velocity. Question 6. A car is accelerating along a level road. Only the front wheels of the car is driven by the engine. So it's saying that actually the front wheels are the engine wheels. So which diagram is correct? It will be B. The front wheels are the engine wheels. So it's going in this here. Friction opposes motion. So the engine wheels. So since friction opposes motion, the force is forward here. The back wheels are just being dragged along. So the friction is in the opposite direction. Question 7. Two copper spheres, P and Q, are at rest on the frictionless surface. The same force acts on P and Q for the same time t. The volume of Q is less than the volume of P, which means the mass of Q is also less than the mass of P. Which quantity is the same for both objects? So since both of them are copper, they have the same density. For kinetic energy gain, okay, the formula is half mv squared it will be different because the mass is different. As you know, the mass was different already. Weight is W equals to mg. So if the mass is different, the weight is different. Question 8. A metal cube with a mass of 15 grams m. Each side measures 4 cm, the length. The density of the metal is 3.0 grams per centimeter cube. Density, rho. Using the triangle MVP. Okay, so there is an empty space in the middle of the cube. What is the volume of the empty space? Let's find V. V is equals to mass over density, which is equals to 15 over 3. So it's 5 centimeter cube. Okay, since we know each side of the cube is 4 cm, we can actually find the total volume, 4 times 4 times 4, minus of the volume of the metal. We actually get 59 centimeter cube. Okay, question 9. A man is carrying a load at the end of a light stick. He rests the stick on his shoulder at point P, which acts as a pivot. He keeps the stick in balance by exerting a force F with his hand as shown. So for questions on moments, we always go, first one we find is the pivot. Pivot is at P. Second, we draw the line of action. So here, be the line of action for the 24 newtons. This will be the line of action for force F. This will allow us to find the perpendicular distance to the pivot. Okay, so the third line of action is using principle of moments. So our anti-clockwise moments will be 24 times 0.5 equals to our clockwise, which is force F times 0.3. We will find that F is equals to 40 newtons. Okay, but now the question is asking what is the upward force on the shoulder. Okay, so we have to use translational equilibrium, and that force will be 24 plus 40 newtons is what it will be experiencing upwards. So the upward force should be equals to the downward force. Okay, question 10. A builder has 4 piles of bricks. Each brick is 0.2 meters long, 0.1 meter wide, and 0.1 meter high. Each block has a weight of 10 newtons. Okay, so that's the force. And which pile of bricks produces a pressure on the ground? So what you can use the formula is P equals to F over A. And just find the combination that produces 2000 Pascal. Question 11. A barometer is set up as shown. So the liquid have a density rho of D. The air has a density of small p. The gravitational field strength is G. What is equals to the pressure of the air? So we use the formula P, small p, equals to H rho G. The H here is not X, not the slanted height, but the vertical height, which is L. Rho, we use the density of the liquid, D. G is just G. So answer is A. Question 12. A stone is dropped from rest at the top of a cliff and falls through the air, experiencing air resistance. So here, air resistance is present before hitting the sea. The stone falls, it loses gravitational potential energy P, GPE. And as the stone hits the sea, the kinetic energy is K. So since air resistance is present, your GPE will definitely be more than your KE. Principle of energy is always conserve or always obey. And the energy is actually lost to other forms such as to heat and sound, friction. Okay, question 13. A lorry is traveling at constant speed V along a highway. The forward force is F. What is the work done? Question mark. For a distance, displacement small s of 100 meters traveled. So use the formula. Work done equals to force times displacement. Question 14. A force F is used to pull a block weighing 20 newtons up a smooth incline as shown. So as it goes up, it gains a height of 3 meters. So first equation you use is GPE is equals to mg, equation 1. Then you can use work done equals to force times displacement, second equation. Here the displacement will be 5 meters because it is translated from here to here. Okay, so you can equate both equations. mg equals to F times S, and you can find F. Question 15. The diagram P shows a fixed mass of gas in a container. The piston is raised slowly to increase the volume. Volume increases. The temperature remains constant. So let's use the equation PV equals to nRT. These are all constants. Temperature is constant. When volume increases, the pressure will naturally decrease. So since speed is proportional to temperature and it's a constant, since temperature is constant, the speed is constant, and now the particles will actually hit the piston less frequently and the pressure decreases. Question 16. A gas burner is used to heat water in a cooking pot. So how does the thermal energy from the Bunsen burner pass through the glass? So they're only actually talking about this part. So this part is actually conduction, which is actually vibrational motion. If it's inside the fluid, what we'll have is convection currents. Okay, next. Question 17 is not tested. Question 18. A regular swimming pool is 12 meters long, 8 meters wide, and have an average depth of 1.2 meters. This will actually give us the volume. A heater increases the temperature of water from 20 to 29 degrees. See, so this is delta theta, which is a change in temperature in 24 hours time t. The density of water is given. The specific heat capacity is 4.2 small c. No energy is transferred or lost to the surroundings. Now they're asking what is the power, question mark. First equation, P equals to energy over time. And we can write it as energy equals to PT. Second equation, Q equals to MC change in theta, because there's no change in state. So we can equate both equation 1 and equation 2. Since Q is equal to energy, PT equals to MC change in theta. And you can use it to find power. Question 19. A sample of warm liquid has a mass of 50 grams. You put small m. The energy transferred from the liquid at a steady rate of power, 200 watts. The student records the temperature at regular time interval. The graph shows the results. So you can use the same equation as we had before. E equals to PT, equation 1. And similarly, Q equals to, but this time is M, latent heat of fusion. Okay. So similarly, Q is the same as E. You can equate both of them together. and you can find the latent heat of fusion. Latent heat of fusion LF of the sample. Question 20. A block of 2 grams of aluminium needs 36 joules of thermal energy to increase its temperature from minus 10 degrees to 10 degrees C. So M, this is Q, and this is delta theta. Okay, using a formula, Q equals to MC change in theta. We have 36 equals to 2.0 times small c, change in theta will be 20 degrees C. We get C equals to 0.9. And what we do is that now the question wants you to find specific heat capacity small c over big C. So big C is actually equals to MC, which is 2.0 times 0.9 equals to 1.8. So the question wants small c over big C, 0.9 over 1.8 equals 1 over 2. Question 21. Which example give a longitudinal wave and a transverse wave? So all EM waves are transverse wave, or sound wave are longitudinal wave. So answer D. Question 22. The diagram shows a part of a long stretch spring. The longitudinal wave is traveling along the spring. So this is where compression is. So in between two compression is the wavelength. So the spring moves back and forth between two positions that are 1 centimeter apart, which is actually the max and minimum displacement. So looking at the graph, it's actually this 1.0 cm, where the max and the minimum displacement are. So amplitude is just 0.5. Question 23. A wave travels at a speed of 1.4 km per second. That's the velocity. Make sure you change to meter per second. Wavelength, lambda, of 0.7 millimeters. Make sure you change to meters. What's the frequency of the wave? V equals to F lambda. Question 24. A diagram shows a thin conversion lens forming a real image on an illuminated object. So what happens when the object is moved towards the focal point F? So remember that this object is actually at in between F and 2F. Okay, so when the object moves closer, you can actually draw it out. You have the same line. Okay, but now you realize that the object will be larger. So as it moves further away from the lens, it increases in size. Sorry, when the image moves away from the lens, it increases in size, and the object moves towards the focal point F. Question 25. Light is shown on a transparent plastic block in air, as shown in the diagram. Okay, so let's look at C. When it enters a optically denser medium, it should bend towards the normal. Okay, and at point Y, because this small c, the angle of this small c is greater than the critical angle C. So total internal reflection occurs like this. Okay, next question 26. Which does not involves the echo of an ultrasound. So ultrasound is still sound, so it's a longitudinal wave. So longitudinal wave requires a medium. So in space, it's a vacuum. Okay, so sound cannot travel in space. Question 27. The diagram represents a sound wave. Then the sound is changed so that it's louder. So loudness is proportional to amplitude. And a lower pitch, which is proportional to frequency. So louder wave, high amplitude, lower pitch, lower frequency. So you just need to find the one that is C, which is a higher amplitude and lower frequency. Question 28. A negative charge rod is brought near a Earth metal sphere. So which one shows the correct charge distribution? Let's look at B. B is the time where the charge haven't moved yet, and once you earth it, the charges, electrons, are the one that move, and you move down into the Earth. And then it will result in A, the final state. Remember that only electron moves. Question 29. There's a current of 0.3 ampere in a wire, I. The charge of electron is 1.6 times 10 to the power minus 19 CQ. And then they are asking you what's the rate of electron flow and in which direction. So we have the formula Q equals to IT. We sub in 0.32 for I, and time put 1 second. So per second, because they wanted the question wanted per second here. Okay, so we get 0.32 charge per second. Now they're asking you for the rate of flow, which is equals to 0.32 divided by the number of electrons, which is 1.6, the charge of the electrons, times 10 to the power 19 C, which actually will give you 2 times 10 to the power of 18 electrons per second. Because you see the column C and C on the top cancels off each other. And as we know, if current moves from left to right, the electron flow is actually in the opposite direction of conventional current. So it's from right to left. Question 30. The student has 6 cells. Each of it is 1.5 volts. Which one gives a total of 6 volts? So this is 1.5 plus 1.5 plus 1.5 minus 1.5, since the opposite direction, plus 1.5 plus 1.5 and plus 1.5. So actually in this example C, 4 times 1.5, 6.0 volts. Question 31. When a charge of 15 coulombs Q passes through a resistance in 10 seconds, small t, work done is 60 joules, capital W. What is the current in the resistor, question mark, and what is the potential difference, V, question mark. First formula, V equals to work done over Q. And the second formula is Q equals to IT. Question 32. The circuit shows a battery, 3 resistors and 2 ammeters. So they have given you that the EMF is 12 volts. I1 is this, and it splits up to I2 and I3 for parallel circuit. Then after that, it joins back up to become I4. So let's write the properties down. I1 is equals to I2 plus I3 equals to I4. I1 has been given 4.0 ampere. and I3 has also been given 2.0 ampere, which means you can find I2, which equals to 4.0 minus 2.0 equals to 2.0 ampere. And because since the current is equal in I2 and I3, which means the resistance Rx is actually equals to 3.0 ohms plus Ry. So the only combination that will allow this to happen is when X is 6 and Y is 3. So here it's 3.0 ohms, X is 6.0 ohms. Question 33. The diagram below shows a potential divider circuit with a fixed resistor of 2.0 kilo ohms. At room temperature, the resistance of the thermistor is 6.0 k ohms, and the potential difference across the fixed resistor is 1.8. So here at room temperature, 6.0 k ohms, this is 1.8 volts. So just quickly using the formula, V out is equals to R1 over R1 plus R2 multiply by the EMF. So with this, you can actually find that 1.8, the values, R1, this is R1, this is R2, R1 is 2.0 K over 2.0 K plus 6.0 K times the EMF. You find that the EMF equals to 7.2 volts. So here, 7.2 volts. And when the circuit switches on a fan, the resistance drops to 2.0 k ohms. So if we were to redraw the circuit, it will look like this now. 2.0 k ohms. The variable resistance also becomes 2.0 k ohms. So if the EMF is 7.2 and the both resistors are of same resistance now, the 7.2 will be shared equally. So it becomes 3.6 volts each. Next, question 34. What's the purpose of a fuse and where is it wired? The fuse is to prevent excessive current from flowing through, overheating the wires. It's usually placed in the live wire. Okay, which of the following statements about magnet is correct? They are not made of pure iron. They can be made of iron or sometimes steel. Okay, a magnet must always have both south and north poles. Okay, the north pole of a magnet points towards the Earth's geographical north pole. Okay, there is force of attraction, which is wrong, repulsion between like poles. Attraction is for unlike poles. Question 36. Which action is used to demagnetize a magnet? So usually you put in a coil, a solenoid, and you run AC, alternating current, to actually confuse the magnetic spins. And then you can actually demagnetize a magnet. Question 37. The wire carries a current at right angles to the magnetic field between two magnets. Which is the direction of the force? So here we will use Fleming's to find force, left hand rule. So here the current flows from positive terminal to negative. We're always talking about conventional current flow. So I is in this direction. So magnetic field. So using the Fleming's left hand rule, let's find the mother from north to south. So from right to left, the current is into the page, and hence the force is B, upwards. Question 38 is a screen of a CRO. cathode ray oscilloscope. Okay, what happens to the waveform when the rotation is half? So once the rotation decreases, you should see the amplitude half and the distance double since the frequency is lower. Question 39. A light shines into an open box and there's two leads connecting to a box and a sensitive ammeters. Okay, so once the magnet moves towards the box, you see that the ammeter deflects. It's because of Faraday's law. Here. And it should be because there's a coil inside. Okay, because the coil is trying to resist the motion of the bar magnet. Okay, so if the bar magnets have a north pole here, a south pole here, the coil will also have a north pole and a south pole. Question 40. Yeah, this is not tested, and that's all for this.